This last one is an example from an AP calculus test of how they can use the intermediate value theorem. Now, we're not going to do all parts of this. We're just going to do part A, so you can just like cross off part B. So the functions f and g are differentiable for all real numbers, and g is strictly increasing. The table above gives values of the functions and the derivatives at selected values of x. The function h is given by h of x equals f of g of x minus 6. Now we're focusing on function h there. And we're asked to explain why there must be a value r such that 1 is less than r is less than 3, and such that h of r equals negative 5. So kind of the same thing we did in the last one. So we're going to do plug in 1. We're going to plug in the left and the right bounds. So let's plug in 1. So we're going to do f of g of 1. Now I'm going to switch colors here. F of g of 1. And then we got that minus 6. So we got to do that g of 1 first. Now we don't have the actual function, but we have g of 1. G of 1 is 2. So we can replace g of 1 with 2. So let's do that. So we got f of 2 minus 6. Now f of 2, again, we don't have the exact function, but f of 2, we can figure that out. That's 9. So this ends up being 9 minus 6, which when you do that simple subtraction, we get 3. So h of 1 equals 3. Now plugging in the left bound, we're going to do h of 3. It's going to be the same setup, but instead of f of g of 1, we're going to do f of g of 3. Then we still have that minus 6. Now g of 3 in this case, we've got it at 4. So it's going to be f of 4 minus 6. And f of 4, we can find that from our table, is negative 1. So this ends up being negative 1 minus 6. So kind of cleaning this up, h of 3 equals negative 1 minus 6 gives us negative 7. So by logic, we got negative 7 is less than negative 5, which is less than 3. In other words, h of 3 is less than negative 5, which is less than 1. Sorry, h of 1. And so therefore, by the intermediate value theorem, there must be some value and we can call that value r in that range from 1 to 3. Actually, I guess we're not including 1 or 3, so we're going to use 1 comma 3. And again, that just means, I'm not going to bother writing it. Such that h of r equals negative 5. Again, kind of applying a visual to it if you do a very, very, very rough sketch of it. At h of 1, we're up here at 3. And at h of 3, we're down at negative 7. So again, logically, who cares what happens in between there? At some point, it's going to have to cross that y value of negative 5.